Hello everyone, welcome. Myself Ayush Sagar Khatkar, student of SYB Tech Mechanical from RIT Islampur. Today I am going to share a presentation on manufacturing of cylinder liner. So let's get started. So first of all, what is cylinder liner? Some of you who are watching this video might be knowing what is cylinder liner. Cylinder liner is nothing but a thin-walled hard metal cylinder inserted into a cylinder block of an engine and in which the piston runs. The cylinder liner is a sleeve in which the piston of an engine reciprocates. As you can see in this figure, this is the cylinder liner and this is the piston, and piston reciprocates in upward and downward direction inside the cylinder liner. There is lot of friction between them, that is between cylinder liner and piston. So the material used should also meet those properties or those requirements. So this is the process flow chart of cylinder liner. See how the process are there. First is decide method of casting. Second is raw material selection. Third is metal of melting of cast iron. Fourth is die cleaning. Next is die coating. Next is pouring of metal into die. Next is centrifugal casting. Next is casting removal. Next is dimensional inspection. And next is further machining processes in the machinery shop. So we will start with the manufacturing of cylinder liner stepwise. First step is deciding the method of casting. So these cylinder liners are manufactured by using centrifugal casting process. This method is normally used for medium and high speed engines. Second step is raw material selection. Cylinder liners are generally made up of grey cast iron, which contains graphite, making it suitable as a natural lubricant. So these cylinder liners are generally made up of cast iron. Some of alloying elements we mix are chromium, molybdenum, nickel, copper, vanadium, titanium, phosphorus, and silicon to improve its mechanical as well as chemical properties. So these are some alloying elements added with the cast iron to improve the mechanical and chemical properties of the cylinder liner. So next step is the melting of cast iron. Melting is the beginning of the casting process. In this step, pure metal is melted in the induction furnace and allowed to heat at very high temperature to totally transform any metal pieces into liquid form in the crucible. In the induction furnace, a coil carrying AC current, you can see here is the induction furnace, and this is the coil. This coil carries AC current and it is wounded around a chamber. ED current are induced in the metal. Because of this AC current passing through this coil, ED current is passed to the metal which is present inside this chamber. ED current are induced in the metal. The circulation of this current producing extremely high temperatures for melting the metal. So as the ED current passes to the cast iron, the temperature of cast iron increases and cast iron starts melting. The temperature range of this induction furnace to melt cast iron is 1150 degrees Celsius to 1300 degrees Celsius. Is die cleaning. An operator or robot puts the die in an empty process tank. You can see this is the process tank. The die are rinsed in the process tank with a heated NaOH solution. The die are rinsed with water in the same process tank. The bath is drained and the operator robot can remove the die from the tank. First of all, in this die, heated NaOH solution is being filled and in which die is being rinsed and it is being cleaned. After that, this NaOH solution is being removed from the tank and water is being filled in this tank and the die is again rinsed in the water and all the bath is drained out from the outlet and the die is cleaned. Next is die coating. Die coating protects the surface of die from molten cast iron and prevents the erosion from occurring. Once molten cast iron begins to erode the die, casting will stick or drag on the die and eventually wear it down. So die coating is nothing but to prevent our die from corrosion and wear. Next is pouring molten cast iron into die. The molten cast iron from the crucible is poured into a centrifugal die cavity to get a right form. Metal is poured into die at one end and centripetal forces transfer the metal evenly along the length of the die, building up a wall thickness. Certain alloying elements are also added with the proper percentages onto the treatment ladle prior to casting. For example, we can add grey cast iron, silicon, carbon and other additives to cast iron to refine its surface, chemical, composition, weight as well as resistance to high temperature and pressure. So you can see here, this is nothing but the container in which or we can say it is our die, or we can say it is our mold. This is the crucible in which our molten metal is present. This molten metal is poured in this tank through which it is passed to the die. You can see this molten metal is passed through the even length of the die. The pouring process. Next is the main process, that is centrifugal casting. Centrifugal casting is heart of our cylinder liner manufacturing process. At this step, the molten liquid having the right specification is poured into a spinning mold that rotates at high RPM. RPM is around 1400 to 1800 RPM. The constant spinning produces a centrifugal action forcing the metal into inside of wall of the die to produce a hollow cylindrical shape until it cools on and solidifies. During the process, the impurities are left in the diameter of the tube, which will then be machined afterwards. You can see this is the centrifugal casting process diagram. This is our die. It is being rotated with the help of motors. You can see here two rollers are there and the shaft is attached to the motor. So as the motor rotates, the rotary motion is transferred to the rollers. These rollers transfer the rotary motion to the our die. So the die rotates and the molten metal is transferred evenly along the length of the die, and a hollow cylindrical shape is produced. So this was the centrifugal casting process. You can refer this figure to understand the centrifugal casting process. Here is a small video through which you can understand what is centrifugal casting. You can see the molten metal from the crucible is poured into this tank, through which it is passed through to the die. Our die is being rotated by these two rollers. Shaft is being attached from these two rollers to the motor. So as the motor rotates, this roller rotates. As this roller rotates, our die rotates, and the molten metal is transferred to each and every portion of this die. So after that is casting is removal. So the casting from the die is removed after the solidification is completed. So you can see how the casting removal is done here. This is how cylinder liner looks like when it is removed from the die. Then next is the dimension inspection. This inspection is undertaken to ensure casted part meets the dimensional requirements and tolerance. So this is the casted part. This inspection is done that to see that the casted part meets or matches the requirements which we need. So these are some of further machining processes which are carried out to the casted part. So this is rough boring. Rough boring is process that comes after centrifugal casting, in which any suspended metal or scrap metal are prepared the hole for finishing. Means the inside hole is properly finished in this rough boring process using automated vertical machining centers. So VMCs are used for rough boring. Next process is fine boring. Fine boring process where we perform a complete refinement of bore that is produced during rough boring. That is, more refinement is done in this process than rough boring, so more accuracy is obtained. This is where we machine the hole to achieve a close bore tolerance. So close tolerances are being achieved through this fine boring process. Center axis positioning and exceptional surface finish are also being achieved through this fine boring. Next process is semi-finished outer circle turning. Using a high-performance lathe machine, the cylinder sleeves are turned by piece to perform rough refinement of outer diameter surface. These operations involve cutting of outer surface based on material drawing specified by the client. So in this semi-finished outer circle turning, outer surface of the cylinder liner is being machined. In the same machine, we also perform inside diameter turning from groove location for PC rings. So for PC rings, inside diameter turning is also being done on this in this process of outer circle turning. Same machine is used for inside diameter turning. Next process is outer diameter CNC turning. With a fully automated CNC machine, We perform outer diameter turning to further enhance the dimensional accuracies, geometrical parameters, and surface roughness of the grooves and bore. So using this CNC, more dimensional tolerances are being achieved, more accuracy is being achieved, more geometrical parameters are being achieved, surface roughness is achieved, etc. Next is CNC honing. We utilize a fully automated CNC honing machine to create a best running surface for fitting the piston rings and uniform orientation of the inner hole and further enhanced. So CNC honing machine is used to create the best running surface along the length of the cylinder liner, also for fitting the piston rings. Next is the coreless milling process. Utilizing a zinc-on milling machine, scavenged air ports are produced on the cylinder liner. Scavenged air ports means I can tell that scavenged air ports are useful for air intake and outtake for combustion process. This is so much necessary for combustion process. This is done through coreless milling process. Next is the final inspection. Finally, the quality experts do a final inspection of the cylinder liner based on the standard drawings which are being come from design departments. This critical process is essential for service life and reliability of the cylinder liners. Instruments which are used for the final inspection are like digital vernier caliper, digital micrometer, roundness tester, because cylinder is a roundness shape, roundness tester is necessary, pneumatic plug gauge, pneumatic ring gauge, and etc. Devices are used for this final inspection by quality control department. Next is laser marking. We use laser marking equipment to place company's brand or logo. We know that company's brand or logo is printed on each and every product which is being manufactured. So finally, I conclude through this activity, we studied the following points. First is water cylinder liners. Second is materials used for manufacturing the cylinder liner. Next is the casting process. In the casting process, starting from raw material selection, melting of metal, die cleaning, die coating, pouring, casting removal, and further machining process which are carried out. All these we studied. So I think you like this presentation. Anything you have doubts, you can ask me in the comment section. I will answer your doubts. So I'll stop here. Thank you.